Good morning, good evening, good afternoon, everyone, and welcome. I see we still have participants joining in. We are about 2 minutes past the hour, so I will begin, and as others join, we will welcome them to our conversation. So I'd first like to start by introducing myself. I'm Edith Wilson. I'm going to be your moderator for today. I'm a fellow of the SEG, and I'm delighted to help to present the first in our series of discussions on critical minerals and economic geology in the new global energy economy. And I'm going to begin in just a minute with a little bit of survey information. But before I do that, I want to let everyone know as you join that the webinar is being recorded and will be available to the public on the archived event page of the SEG website at segweb.org, as well as on the SEG YouTube channel. So we will be having a wonderful discussion today on the critical minerals supply chain with an overview and 3 very special guests. But before we get to introducing those guests, I'd like to tell you just a little bit about the Society of Economic Geologists, which is an international association devoted to the advancement of science, discovery, and responsible development of mineral resources. I know that many of you are already members of SEG. If you are not yet, I invite you to check out our benefits, which include networking, education, training, scholarly publishing in our wonderful Journal of Economic Geology, and conferences, including our flagship 100th anniversary conference that is coming up this fall to be held possibly virtually and in person in Whistler. We especially welcome all of the students and early career professionals who are with us today. Students at SEG are so critical to our future. We use over $500,000 annually dedicated to student support. We have over 100 student chapters in 33 countries. And we just love when those students turn into early career professionals, and we welcome you all as well. We hope that today's conversation will not only result in your meeting 3 people who have stood where you stood very recently and are going to share their stories with you, but we also hope that we will be able to give you a lot of good information for surviving in a changing world. So at this point, we have a few survey questions for you, just so we can see of the 200 of you who are joining this call. It's delightful to see so many wonderful participants. We'd like to ask you a few questions about where you are and who you are, so that we can have a better understanding of our audience. So let's go ahead with the survey. And you can simply answer these in order in your own time. And panelists, you're welcome to answer these questions as well. The first question is about your industry career service, and then a little bit about age and geography, demographics, and finally about employment status. So I invite you to spend a few moments scrolling through and answering the questions. And as soon as our behind the scenes wonderful staff, Deanne Ryder and Duncan Proctor, are able to analyze all of your results, we will see a little bit about who we are talking with before we begin. So again, I just want to remind you that if you have any questions, want to see a recording of this event today, would like to know more about membership benefits or about student benefits at SEG, please visit the website, which is at segweb.org. And all of that information is available to you from there. So I see we are leveling out at around 200 participants, and at any moment we will see the results of our demographic survey. There we are. Okay, so we are looking at about 40% industry professional, a good scattering of students of all levels, and a nice round out of academia and government. We are looking at a young and very broadly distributed age group. A lot of folks from North America, but delighted to see our friends got up early in Australia, and lots of you joining us from South America, Central America, and Europe as well as some folks from Asia. I don't even know what time they must be at this point. What a great group. This is just fantastic. And then we are looking at students, those who are employed, those who are looking for employment, and retired. So we have a wonderful and broad group of participants today. I'm really, really delighted to welcome you all. And again, for those of you who are just joining us, my name is Edith Wilson, and we are having our inaugural webinar of the Critical Minerals series. It is being recorded and will be available for free to the public later. So Deanne, can we go to the next slide, please? So this is representing where we want to cover in this seminar series. The SEG is delighted to contemplate a 4 or 5 sequence series of discussions about the energy supply chain and specifically the critical minerals that are going to be needed to build it. And we are going to take this apart from soup to nuts in this conversation. We're going to talk about mining. We're going to talk about refining and processing of critical minerals for energy storage. We're going to talk a little bit about developing new chemistries and structures for cathodes and anodes. And we're going to talk about recycling. We're going to talk about the market for those minerals as well. So this first session of our critical minerals series is entitled Mine to Market, meaning just an overview of everything in the critical minerals supply chain. And we're going to focus on where we as energy geoscientists, as economic geologists, where we can make a difference in all the links of this supply chain. In subsequent seminars, we're going to look in detail at one or more of these links. We may have a discussion about the ore deposits that underpin the upstream side of the mining cycle. We may have a discussion about new battery technologies and what new minerals may be needed on the market. But we will focus today on a broad overview, and we are delighted to have with us some guests that will really give you a flavor for how important it is to understand the entire supply chain for energy minerals. Okay, we can have the next slide, please, Deanne. Our agenda today is really simple. We're glad you're all here. We have a little data from you from our participant poll. Our next step is going to be the introduction of our panelists, and we're going to have them tell you their stories themselves. And then we will have whatever remaining time of our hour and a half together for questions and answers. I have a few starter questions, but we encourage you, please, to post your questions as a group in the Q&A. We'd like to reserve the chat for if you are having any difficulties in logging on or communication. But for your questions, please go to the Q&A button with the 2 little balloons in the bottom center of your screen and post your questions. You will be able to upvote your questions as well. So feel free to go ahead and begin posting questions at any time, and we will take them as they come as we move through the appropriate topics. So with no further ado, we will finish our thoughts just a few minutes before the closing of the hour and a half, and then we will ask you for a little feedback at the very, very end. So again, welcome, and let's begin. So we'll take the next slide, please, Deanne. Great. So the first thing I'm going to ask is for Lucy Crane, who is our panelist, whose area of most expertise is on the mining side. And I'm going to call on Lucy to please introduce herself, tell you her story, how she got to be where she is today, and some interesting mileposts along the way. Thanks, Lucy.
Brilliant. Well, thank you, Edith. And thanks everybody for asking me to come along today. It's a fantastic event and it's a real honor to be involved. So, yep, as Edith said, I'm a geologist. I'm a geologist by training, and I work in the exploration side of the mining industry. Whilst I was at university, I really enjoyed what I was studying and I wanted to do something that meant I could apply all this knowledge that I'd just gained in my future career. And so I actually did an internship with an oil and gas company when I was in my penultimate year. And I spent 3 months living in central London. I'm based in the UK, living in central London, being paid the proper wage for the first time. And I spent the entire time sitting at a computer looking at seismic lines. And I just remember finishing those 3 months and thinking there has got to be something more interesting that I could do with my career. And through various connections, I ended up going to a place called the Camborne School of Mines and studying mining geology, and just felt like I'd found my calling. All of a sudden, we were actually learning. My undergraduate was really quite academic and theoretical, and then all of a sudden we were applying it to things. And it wasn't just the geology. We were also looking at the economics of projects. We were looking at mineral processing, and once you found these mineral deposits, how do you actually extract it? And it gave me a sense of quite how varied and interesting the minerals industry could be. So I started off my career with a company called Outer Strategies, exploring for base metals out in Morocco and Ethiopia, which was awesome, hiking around with a rock hammer, camping in the middle of nowhere. And it was fantastic for a few years. And then I've been lucky enough to join a company called Cornish Lithium. So we're based down in the southwest of the UK and exploring for lithium from what have previously been considered unconventional sources, lithium from geothermal waters and lithium from mica minerals as well, from the hard rock. And so in my role at Cornish Lithium, I started off as an exploration geologist, but actually as the company has developed, moved into more of a communications and ESG role. And we're very involved in the conversations around the energy transition in the UK and Europe, and looking to provide the raw materials, because lithium is such a key component of lithium-ion batteries and electric vehicle batteries. And, you know, there's a huge conversation that's happening in Europe at the moment about where on earth are we going to source these raw materials from if we want to build these EVs ourselves. So I'm really looking forward to the conversation tonight.
Excellent. Thank you so much, Lucy. Deanne, can we have the next slide, please? And now I'd like to ask Jesse Edmondson to introduce himself.
Yeah, thank you, Edith. Pleasure to be here with you guys today, especially with such a kind of an all-star panelist group of panelists. So I'm Jesse Edmondson, born and raised in Fort Smith, Arkansas. Went to schools to study geology. Got a bachelor's and master's from the University of Arkansas, but the program I went to, which is like a lot of the universities across the U.S., at least in the early 2000s, where it was actually hard to study mineral exploration or hard to study mining. The geology program I was with was very much encouraged oil and gas exploration, which certainly, nothing wrong with that, but it was just something that never quite interested me intellectually or just kind of where my ethos were at. And so I actually ended up spending most of my academic career studying climate change, and doing that via dendrochronology, or tree rings. So studying old growth forest and doing a lot of work reconstructing drought, things like that, understanding climate variability across mainly the United States. I got out of school and decided I probably ought to try to get some street credit as a geologist, and went out west to East Central Nevada and worked on a gold silver project for a year. The investors that were behind that project quickly moved me to Alabama to get a graphite project started. This was right around 2012, right when the kind of the first Tesla Gigafactory was announced, and when there was going to be all North American supply chains to supply that Gigafactory as per Mr. Musk. And so I was part of that kind of first wave of exploration, trying to create domestic supply chains to support that initiative and the emerging opportunities that were going to be presented by that throughout the country. Through that role, again, was mainly I've been in the exploration side, as I've been a professional geologist, but also had some other opportunities to do business development work. Hopefully something that we'll discuss today, and Lucy and Andy are both very aware of, is that with these critical minerals, it's often about the advanced processing as well as the mining. So really trying to learn about the supply chains and how to break in as a new supplier. And it turns out it's very complicated. It's not just mining a material and then selling it right when it comes out of the mine. So really understanding the kind of the dynamics of that. And then also got some exposure to doing government relations work around critical minerals, both at the kind of the local state level and also at the federal level. A couple of years ago, decided to leave that company to start my own venture. So I do consulting work through a company called Critical Resources Consulting. And then I founded a company called US Critical Minerals, which is a private company kind of set out to build out a portfolio of best critical mineral assets, mainly focused on battery metals and rare earths.
Great.
Thank you.
Thanks, Jesse. Appreciate that. And I know that there's going to be a lot of conversation over this importance of the processing and refining piece and the impact that has on the upstream. So great. Deanne, I think we're ready for Andy to introduce himself and talk a little bit about the markets end of things.
Thanks very much, Edith, and thanks to you and the team for inviting me along today. As you can probably tell by this picture, I am not a geologist or a geophysicist. As you can see by Jesse and Lucy look so comfortable on a mine site, and I am very much not, as you can see by that picture. But my background is as an economist, so I studied economics. University, left and did the usual thing that economists do and followed the money into the investment management industry for a couple of years, where I was a young and impatient professional and wanted everything to happen overnight, and quickly became frustrated that it wasn't. So at that point, through some connections and through some people I knew, I got offered a position at a company called Industrial Minerals. There I focused on market research for the weird and wonderful world of minerals and metals, and niche minerals and metals specifically. So covering those, I looked at potash, looked at fluorspar, graphite, lithium, looking at these type of things, and quickly came to realize what a complex world and complex supply chain it is for a lot of these minerals, but really became fascinated with, the vast range of applications and different types of markets that they were serving and so critical to, and I'd never even heard about before getting involved in industrial minerals. So that was a really exciting part of my career where I learned this passion, if not for the understanding the technical and the really advanced stuff that Lucy and Jesse can talk to a bit more about. And I'm sure a lot of people on this call can talk about, but specifically on the market research side, I really got interested in, the applications, and in particular, the use of some of these niche minerals and metals in the sort of new energy economy, I suppose. So in 2015, my then boss, and still boss now, Simon Moores, left and started a company called Benchmark Mineral Intelligence. I joined him, and we established the company as really a platform for independent price collection and market intelligence, specifically for the lithium-ion supply chain. A lot of the minerals we've been working in had this emerging application that at that time was a very tiny slither of the market, and we were never allowed to spend too much time on it, but was the big growing part that we were really fascinated by and wanted to know more about. So Benchmark was set up, like I say, to focus on the lithium-ion supply chain. Since that point, we've established price assessment services, market assessments. We do long-term supply, demand, price, cost forecasting, all of that data-heavy, number-driven stuff that goes into the economics of some of these projects. So I've been really privileged to, grow the business and be involved in a lot of strategy work, working with a lot of major participants along the supply chain, And particularly at this point, with the emergence of batteries and with the growth in the electric vehicle market, being able to work with some of the automotive companies, some of the new participants in this supply chain and stakeholders to really build out what's such an exciting future for all of these industries, and having an understanding of the supply chain, and in particular the upstream part of the supply chain, which maybe hasn't received the attention it deserves up until now, but is such an important point of the planning for those downstream ambitions, has been really exciting and something I've really enjoyed. So that is my take on things, coming at it from a slightly different angle. But again, thanks for the invite, and excited to be involved in the Q&A.
Awesome. Great. Well, thank you all. At this point, we're going to stop the screen share and put the four of us back in the middle of your gallery view, so that we can carry on the conversation. And I hope that it's been really evident from hearing the stories of our panelists that particularly in this business of critical minerals supply for energy storage and electric vehicles, it's not really possible to consider one element of the supply chain in a vacuum. Andy knows all about processing and refining and about something about mining, and Lucy and Jesse have to consider how their product is going to go to market before they can even begin to extract it. So the overall message that I know we're going to hear reinforced in our discussion is how interrelated and integral each part of the system is one to the other. So I see we have a couple of questions that have popped into the Q&A, but I'm going to just warm things up a little bit. First, by asking the three of you to feel free to keep your microphones open if you'd like to jump in at any time. But I'm going to pose one general question to start us off, and that is, what do you think is the greatest challenge in your particular arena that we've asked you to speak to today? Lucy in mining, Jesse on the refining and processing side, and Andrew on the market side. What do you think is the greatest challenge for critical minerals supply today? And how can we as geoscientists help to meet that challenge? I'm going to start with Lucy again.
Okay, wonderful. So from a geology perspective, I think the greatest challenge is actually the sheer amount of critical minerals that we're going to need for this energy transition. As we move away from our reliance on fossil fuels and towards this clean, green, renewable energy future, actually that's hugely mineral intensive. The World Bank put out a fantastic report last year called something like the mineral intensity of climate action. And it really paints a pretty stark picture about quite how many raw materials we need to find purely to help us meet this energy transition. And I think one of the most stark of those statistics is the fact that in the last 5,000 years, humanity has extracted about 550 million tons of copper. We need to find that same amount of copper in the next 25 years. So when people say, oh, we need to recycle everything that's in circulation, we need to do that. Absolutely, we really need to start building products that make it easy for us to take components out and they can have second lives and then they can be more easily recycled. But the fact is that over the next few decades, we are going to have to find a huge amount of raw materials. So as geoscientists, we're the ones who have that toolkit that understands where the Earth's resources are and how we can, we then have the responsibility to make sure we're extracting them as responsibly as possible. So it means embracing new technologies for helping us to find these things more efficiently, but it also means embracing new technologies to help us extract them. And absolutely, Edith, as you just touched on, we need to be linked up along that whole supply chain to make sure that things are being designed for reuse and recycling and making sure we are as efficient as we possibly can be with all of these resources.
Excellent. Thank you, Lucy. And Jesse, I'm gonna poke at you next. And I know you and I have had so many conversations about how different this critical minerals business is, particularly for building batteries, because it's not enough just to have a ton of ore. One has to have these very highly specified advanced materials. So how can we, what do you see as the greatest challenge in the refining and processing sector, and how can we as geoscientists help?
Yeah, absolutely. Yeah, I think I'd say three things. So kind of diversification. Okay, so looking at currently where the processing is done around the world and realizing that it's quite centralized for the most part, and many times, in many cases, coming through China. And so I think we need to find ways to kind of diversify those options. And there has been a kind of a huge cognitive dissonance with the fact that it's not just about mining these materials. You can, from a national security standpoint, or just kind of controlling your supply chain as a country, it's one thing to have the resources in the ground and be able to pull them out of the ground. And probably the rare earths example is probably the best one for that, where, in the past, at least in the United States, we actually have the mining capability. We've got the resources on the rare earth side. When we've had supply disruptions in the past, the government has kind of got behind the mining aspect of it without realizing the importance of setting up that downstream capability as well. And as you look across the critical metals of the battery material space right now, you can see that China doesn't use, and the benchmark guys are really the best data point for this. I'll point out that, but it's not just about controlling the ore coming out of the ground. In fact, the Chinese are able to control the supply chain by their dominance of the processing capability as well. And that's, so like the case of lithium, for example, they don't necessarily mine a lot of lithium within the borders of China. They do control assets internationally, but basically most of the world's lithium has to travel through China right now to be processed. I want to be careful to point out too, I'm not anti-China, but it's just the realities of the way the supply chain works right now. And so it's something to be aware of. And then I would say the next challenge is really around, the sustainability aspects of processing. So, processing and refining is chemically intensive in many cases, and it's very energy intensive in many cases. And so finding ways to really improve the environmental sustainability of that, trying to, particularly like on the energy intensive side, how can you match that processing capability with better, cleaner sources of energy, even if it's going from coal-powered plants to gas-powered plants. That represents actually a huge decrease in the overall CO2 footprint. And of course, as you would look to potential options for renewables, then it just gets even better. And then just the challenge of managing kind of parallel development with the mining and the processing capability, making sure that that they're done in unison and one doesn't get kind of too far ahead of the other, because they need to be able to grow together. And the financing of those to allow that to happen in a timely manner is another huge challenge.
Yeah, great. And just as geoscientists, even being aware that those are issues and hurdles to overcome is a big change for us. So how about you, Andy, on the marketing side? What do you see as the greatest challenge to critical minerals supply? And, maybe not something that geoscientists necessarily are directly involved in, but what do we need to be aware of?
Yeah, I think Lucy and Jesse have done a really good job in summarizing a lot of the points I would have made. I'd go back to the point about diversification. I think that is the biggest challenge for this supply chain today. It's required, excuse me, not just from a security of supply standpoint. We're hearing a lot about that at the moment, and the need from a national perspective for countries to have more control over these supply chains. But I think you've also got to look at this from a cost basis, and the work we do looking at trying to map, where are we in terms of battery cell cost, and when is the competitiveness of electric vehicles going to match that of internal combustion engines? And when you look at this continually reducing cost of batteries, a huge part of that is reducing the cost of the raw material, an increasing part of that, right? Because ultimately what you're doing as that battery cell cost comes down is you're making the raw materials a much larger proportion of that overall cost. So, being able to localize the supply chain is important, as I say, from a security standpoint, but it's equally important in terms of being able to produce these materials somewhere else, somewhere other than China or Asia, where it's done at the moment. It doesn't make any sense if you're building an electric vehicle in the US or in Europe to be shipping all of your raw materials around the world 3 times before they're actually going into your electric vehicle. And I think, looking at and attributing value differently to these raw materials is a really important factor. It's attributing value not just to things at a raw material level, but it's getting to a battery grade product that can actually be used is obviously the key one of those. But then, like Lucy and Jesse have pointed out, the issues of sustainability, that adds a different value. And when you're looking at the cost basis of these and the prices that should be attributed to these materials, you have to take into account all of these different factors. So there is a role for the development of raw materials and the whole supply chain in a much more diverse way than we see it today. But it's going to take time, and it's going to take a change in the way companies think about these raw materials.
Absolutely. And I see, in all of the elements that you all have discussed, an increasing role for earth scientists, especially in full life cycle analysis, understanding the cost, whether it be financial or carbon or social license of the product from cradle to grave or cradle to cradle. So really, really important role for us as we go forward. So I'm going to grab a couple of questions from the audience, and one that I see that I think will serve to sort of stir some interesting thoughts, and then we'll move on to some more specific ones. But this one is quite broad. What are the currently perceived potential game changers in the energy storage sector realm? So thinking to the future, what are we going to be talking about differently 5 years from now than we can see on the horizon at this point? So let me pick on Jesse first for this one. What's going to be the biggest game changer in energy storage? 30 seconds or less.
Probably just different advances in battery technology. So whether that's just improving the anode side, going from a pure graphite anode to slowly putting more and more silicon on the anode side to increase the energy capacity. On the cathode side, putting more and more nickel into the cathode, and then making the jump to kind of solid state batteries. I think that, but again, you look at, the science of this, you look at the periodic table, there's certain elements that are always going to be involved in this, right? I mean, we've got what we've got to work with. So lithium is certainly going to be a key part of the story. And, as a guy that's spent a lot of time on graphite, get a lot of questions. When's graphite going to be engineered out of the anode? And I think there's always going to be a place for it. The battery technology is always going to be diverse. If you look at lead acid batteries, it still has a huge part of the overall market. And so, different technologies are going to rely on different battery chemistries based on what's most economic and what's most efficient for them. And then you look at just things in general, the world is still growing. There's still more and more people. And so really all of these sectors are going to continue to grow, which means really growth for all these minerals, kind of as Lucy pointed out, kicking things off. So Andy might have some better, more articulate answers than I do on that, but.
Yeah, that's awesome. So yeah, great. Changes in battery chemistry are going to be game changers. Andy, what other game changer do you see? What could be a big paradigm shift going forward?
You gotta stop putting me after Jesse. He's taking,
okay, sorry.
He's giving you the full answer. No, I completely agree with him. I think it is a more diverse set of battery technologies. I think you're pick my word of the day, diverse. But I think you are going to see, like Jesse points out, you're going to see the emergence and the refinement of whether it be the existing incumbent lithium-ion anode and cathode technologies, where you're seeing a lot more variations emerge, new technologies emerge, or whether it be a complete shift for certain subsegments of the market towards other battery chemistries. And I think it's really exciting, but something that sort of often gets lost in this discussion around batteries. Everyone thinks Tesla, everyone thinks electric vehicles, but there's a huge potential market, not just in the portables and the phones we use, but also in stationary storage applications. And I think that has a really, critical role to play in terms of making energy storage economical, and that plays, of course, into the renewables aspect, how you store that energy and how you increase the use of renewables across the world. So in those type of markets, you don't necessarily need the lightweight characteristics of a lithium-ion battery, but the economics of lithium-ion batteries mean that lithium-ion will play a major role in that market. But it will be a diverse set of battery technologies, like Jesse points out. You're still even going to have your lead acid, although I don't think that will be a technology many are adopting in new applications, but you're still going to have the applications for that. But you're going to have solid state for maybe some more high-end vehicles that will emerge over the coming decade. You're going to have variations in battery technology for the specific applications as they broaden in their requirements.
Great, yeah, and even things like hydrogen or gravity storage, yeah. Lucy, what is going to be the game changer? What's going to be the paradigm shift? What's going to make a difference?
Oh, well, that's a difficult one to add anything in particular extra to. I think the paradigm shift is actually going to be in mass uptake of using battery technologies. So whether that's in policy, that means that people are buying electric vehicles rather than traditional combustion engine cars, or exactly as Andy just said, grid storage of renewable energy needs to happen on a big scale to make it viable for us to transfer over to using renewable energies. So I suppose my answer for this one's probably a bit of a cop-out, in that I think the game changer is actually going to be the mass uptake of these battery storage technologies.
Interesting. Yeah, it's going to be the rate, in other words. Yeah. Okay, so I have a number of questions about, sort of what the next new mineral is going to be, right? So I'm going to sort of wrap a couple of questions together here. In terms of all this new technology you've been discussing, and I'm only going to let you answer just a couple of words. What are going to be the next hot critical minerals that we haven't been hearing about? We hear about lithium, cobalt, graphite. What's the next hot critical mineral that's going to come online? Andy, I'll let you go first.
Yeah, a tricky one. I honestly can't say that I think there's going to be a whole new, like you point out, there's hydrogen, there's solid state. I think what interests me more than anything is not necessarily a completely new mineral, but I think it comes down to some of the chemicals that might be required. And I think that's the really critical step in a lot of these new energy applications is, what are you refining to? What do you have to produce for it to be able to use in those applications? And I'd say, when you do look down the solid state route, of course, there's more of a leaning towards lithium metal, which in today's market is less than 15,000 tons, annually. So it's a very tiny subsegment of the lithium industry today, whereas carbonate and hydroxide. And even within your existing, portfolio of chemistries, you have the question over whether they'll go towards a lithium carbonate versus a lithium hydroxide, or how integrated will nickel sulfate be at the cathode producer level, and where is the raw material producer going to have to provide the material? What is the end product that these battery producers want? And with those variations in technology, it's such a moving target, right? It's so unclear, and which is what makes it so difficult but so fascinating as you see the rollout, is because these raw material producers, you can be an incumbent today and be the leading producer in the world, but if you can't adjust and change your specifications and be adaptable to what you can produce, then you really run the risk that technology sort of outpaces you, and you're left behind with a product that means you're not competitive anymore. So maybe that's quite skirting the question slightly, but hopefully it gives you something.
Yeah, excellent. So Lucy, what's the hot new metal? What's the next thing?
I'm going to steal an answer from a very highly qualified chemist that I spoke to this morning, actually. And she was telling me about her favorite element, which is tantalum. And actually, you can use it in so many different applications. If you want tiny, tiny, tiny capacitors, then you need it. So in hearing aids or things like that. But actually, it also goes on the blades of wind turbines, and it's got so many uses that we're only just finding out about now. So actually, maybe the new next critical mineral is actually going to be us finding new applications for these current minerals that we're already using.
Interesting perspective. Great. Jesse, what's your favorite new mineral that's going to emerge? What do you think?
Yeah, I mean, it's hard to go last with these two. I see what Andy's problem was. Yeah, I would. So I guess a couple things I'd say. So I would definitely add on to what kind of Andy said. It's more the like specific chemicals dealing with the minerals we've already got and how that's going to change. And then I think that as technology itself changes as far as the ability to use these different minerals, so like for instance, like 3D printing and kind of specialized powders and these kinds of things, conductive inks and all this kind of thing, that's going to really unlock a whole lot of potential for a lot of, like, for instance, like with tantalum. And then I think on the rare earth side, some of the specific rare earth elements, I think the more that processing capability kind of opens up and becomes more economically efficient, more environmentally sustainable, to where we have more affordable access to some of the rare earth elements, that we're going to just in general as a society, we'll get more and more familiar with some of the rare earths and kind of the potential that they can unlock technologically, just as they become more available and accessible. Yeah, I don't know. Other than that, that's kind of where I'd go.
Okay, so not surprisingly, we have a virtual room full of geologists who are interested in mining minerals and metals. So we still have more questions about metal supply and demand. And this one, I'm gonna send it first to Andy again, and it's a big supply and demand question. Where is the largest gap in battery metals, and where is the greatest emerging demand?
The greatest emerging demand, from my perspective, is in batteries, is in the energy storage market. I don't think you're going to see anything as persistent in terms of a demand uptick.
And how about geographically?
Oh, where you're going to see it geographically? I think North America and Europe, you're going to see a big step up, but from a very low base. I wouldn't rule out, China has led the way on this front, and there's no signs that China's going to slow down anytime soon. So from a demand perspective, I think you've got to look across these materials, and like we've talked about, look at the technologies and really pinpoint where are the bottlenecks to supply certain materials into those technologies. I'd as Jesse already pointed out, lithium, if you're looking for a battery you can move around, you're going to use lithium. And the chances are that with some of the developments in battery technology, if you see the sort of roadmap for a lot of major automotive and battery companies, is moving towards higher lithium intensity, if anything, and obviously many more unit sales. So I think you've got to watch lithium as a mainstay across all of these. As you pick into those other technologies, there'll be other minerals that are going to see similar growth levels, or certain pockets of those markets that will see similar growth levels, but it will be broad. I don't think you've got bigger headwinds anywhere than in the battery market, like we talked about, not just electric vehicles, all different types of energy that are going to be tied to energy storage.
And what would you say, based on the work that you guys have done at Benchmark, which material has the biggest gap between supply and demand in the coming years?
It is lithium again, I think, when you look at the scale. But I think others have changes. Like you look at, what one I think is going to have real issues, because it's very underestimated in terms of the role it's going to play in batteries, is actually cobalt. A lot of the rhetoric around cobalt has been around the fact that you're going to take cobalt out of the battery. The reality is actually you're going to decrease the intensity of cobalt, but the growth in terms of the number of batteries is going to far exceed that. And actually, because of the byproduct nature of cobalt, it's incredibly difficult to get more of it.
Great. Okay, great. So Lucy, your turn. Where do you see the largest gap in supply and demand? What metal, what mineral, what commodity has got the biggest gap between supply and demand today?
Well, I'm hugely biased towards lithium. I'm working for a lithium exploration company and involved in a lot of conversations in the UK and Europe about how we really need to start thinking about where we're going to source the lithium from. And as the others have touched on, supply chains at the moment are very focused on China. So it's not just where are we going to produce this raw material. We've got potential to produce it in the UK. We've got potential to produce it in Europe. But actually, it's not just producing a lithium product. We need to be able to refine it into a battery quality chemical that can then be used and keep that kind of whole battery ecosystem much more locally. There's such a huge drive from national government and from the people in charge in Europe at the moment, to try and bring that whole production line into the UK and Europe. And I'm sure it's the same in North America and other parts of the world. And actually, that big gap in demand is actually, how do we produce these things ourselves? And how do we produce these battery quality chemicals? So I think that's going to be the biggest challenge over the next few years.
Great. Yeah, and that leads directly into my next question, which you guys have already touched on, and I'm going to throw it to Jesse first, since I didn't give him a chance to answer that last one. I think we were all circling in on lithium, so I'm going to leave it at that. But do governments around the world have policies in place to meet this kind of processing gap that we've all been talking about? How are we going to create a place where processing is distributed and isn't all funneled through one economy? Jesse, what do you think is, do you think that other governments have policies in place, or what policies need to be in place to respond to this need for critical minerals, particularly on-site processing?
Yeah, sure. No, and I would just add one thing from kind of the last question as part of the segue, that Andy and Lucy both touched on it, but I think really where the biggest gap is, and then that's where kind of government policy can kind of step in. It's creating reliable, sustainable, high quality sources of technology ready materials. So whether it's lithium, whether it's graphite, there's one thing to have enough graphite floating around as it's come out of the mine, but to have it in a way that it can be sustainably produced, and you can have enough of a diversified supply where you can really rely on it. The consistency of supply is so important when it comes to these markets. So it's not just about meeting a certain purity specification, but it's also about meeting an impurity specification. All right. So you can, in the case of graphite, you can have 99.99% pure carbon, but what's in that remaining 0.01%? And how does it vary from batch to batch if you're the customer from a particular source? And so that, to me, I see that as really the hugest challenge, and that's really at the heart of the critical mineral story, is how do you have technology ready material that's ready to meet the demand. And so as far as government policies, I would just, in general, you're definitely starting to see a panic and action from governments around the world. So in the United States, under the past administration, with Trump, he's put in 2 different critical mineral executive orders. There was, some different Defense Production Act got enabled as far as finally throwing some kind of meaningful money at the downstream production, mainly of rare earths. And now we've seen a continuation of that with the Biden administration as recently as this week, where there's a new executive order out. And actually I had some recent discussions about that yesterday with folks on Capitol Hill as far as what that meant and how it was different. And the fact that the critical mineral executive order was accompanied with pharmaceuticals, semiconductors, and then the battery technology itself, or the large capacity batteries. The fact that those were all lumped together. Talked to several sources yesterday that was quite meaningful. That it was just about critical minerals. It was really kind of the bigger story and how it all relates. And then there are also some observations about the meetings around this executive order this time of last week. They were very bipartisan. So Republicans were sitting around the table with Democrats, and that's something that we didn't see with the past executive orders. So I'd let Lucy or Andy probably comment on what's happening in Europe over me, just because they've got a little more kind of knowledge about it. But I would say, there is now, I think, across the globe, just a recognition of this is important. These supply chains are important, and they're extremely complicated. And there was a gap, and there has been a gap, that the waving of the arms by the end users, whether it was Tesla or all these other electric vehicle companies, that kind of, if you build it, they will come. We want to have EV technology. So the miners need to get busy, and the people that invest in mining need to get busy making this a reality. And, there was, back when I first got started in this around 2012, there was money that was thrown at exploration. So on the order of a couple $1 million, but in many cases, you had a lot of good projects, a lot of new potential resources were found, but there was a gap in the financing to bring these projects online in a timely manner. And so now we're seeing this panic because we realize, hey, we didn't build these supply chains up enough, we didn't diversify them in kind of meaningful ways. And so now kind of how do we do that now really quickly and efficiently? But again, what's so important is that it's done sustainably and responsibly.
So I'm going to throw that question to Lucy, as you just did. Lucy, what do you see changing in terms of particularly European policy to impact this diversification of supply?
To be honest, I think it's actually just a recognition of the fact that we need to think about the supply. I don't know if that's, Andy might have other opinions of whether that's fair to say, but especially in the UK, it's only really, I'd say, in the last 12 to 18 months that all of a sudden the government seemed to be sitting up and taking notice of where we're actually going to source these building blocks for the energy transition from. In the UK, there's an initiative called the Faraday Battery Challenge, where the government's invested £274 million into developing lithium-ion battery technologies, making sure we're at the forefront of battery technology for the EV industry, which is fantastic. We were lucky enough to win a kind of innovation grant from them a couple of years ago, where it was us, the Natural History Museum in London, and some mining consultants called Woodell Armstrong, looking at the mineral potential. Could it ever be viable to produce lithium in the UK for the UK battery industry? And that was £500,000. And that was the only project out of that whole package looking at sourcing these raw materials. And since then, in the last 18 months, we really have started to see much more attention from government on, actually, we can produce some of these things closer to home, and we really need to be thinking about how we're doing this in the most responsible and sustainable manner. And I think it's fairly true to say that Europe are probably a year or two ahead of that, but yeah, it's all of a sudden on people's radars, it seems.
Yeah, well, Andy, how about the rest of the world outside of the US and Europe? What do you see changing policy-wise to sort of meet this demand gap?
Unfortunately, I'm going to say something that's, I'm sure a lot of people on the call I want to hear, but these minerals often aren't the sexy step in the supply chain, right? They're not the part that captures the imagination until something goes really wrong. And I think that's what you're seeing, in the US at the moment with the chip shortages and some of the focus on supply chains. All of a sudden it shoots to attention. You've seen it in rare earths, you've seen it in various other minerals, and they rise to the top of the pile for a certain amount of time, and then it switches back. And I think what the supply chain for these minerals really needs to rely on is the development of the industry, because ultimately that forces change upstream, right? You see the investment that goes in at the downstream level. You've seen it in Europe, where there's been a huge amount of investment. Probably 2 to 3 years ago, you started to see massive investments at the battery in future battery cell capacity in Europe. And what's happened now is it's taken 2 to 3 years for the industry to start to say, wait, we need to really have our own supply chains here. We're in a similar position in the US at the moment, where I think, you have these industry forces, you have, Europe and North America are such hubs of automotive production, right? They're huge parts of those economies. They can't run the risk that they just completely lose any competitiveness at the automotive level. So now they've got to fix the solution. But unfortunately, we are, the rest of the world is behind where China is. I mean, that's not unfortunate for China, but it's unfortunate probably for North America and for Europe, because what they've done is very successfully built out an entire supply chain strategy, and they have locked in each step in that supply chain. And where they don't even have the raw materials, or they don't have the geological competitiveness, they make sure the refining goes through that part of the world. And now it's really a race, every other country around the world, to make themselves competitive at some level of this supply chain. So I think, unfortunately, it has to come from industry, and I think we're just going to see a continue of these types of stories and certain issues where major bottlenecks emerge for certain countries, and that really throws the attention onto your lithium or onto your graphite or onto your cobalt. But ultimately, the industry is going to have to drive the change along that supply chain.
Great. Awesome. I'm
One more
really
thing
glad we wandered a little bit into policy. I want to, sorry, Jesse, were you?
I was just gonna, yeah, one more thing that, I think that over the last 5 years, we could have really used a lot more government support to kind of ensure a kind of a base case scenario for these markets. There was so much just uncertainty in when the markets were going to really kick in. And because it's so hard to evaluate, a graphite deposit or a cobalt deposit or lithium deposit in the ground versus like a gold deposit, where it has this clear value when it's sitting in the ground. Whereas, with these battery materials, for example, you've got to be able to prove that you can in fact make the battery quality material out of the resource that's in the ground to the spec that the customer wants. And, there's a gap between, investors really funding you to have that capability because of the qualification period involved with all these materials. But that's where, the government, I think, could have stepped in over the last couple of years and kind of created that certainty and a little bit of just a kind of a safety net to where it would allow the industry to grow and be ready for kind of what's coming. But I think, and I'd be interested to get Andy's comments, I think now what we're seeing is the fact that it's being more market driven, where the certainty is there, that kind of that first wave of excitement that I think we were, all three involved with over the last 5 years that kind of came, and then there was a lull in 2017, 2018, 2019. And now we kind of see this big wave coming. And I think, now the certainty is there, but it's because now you can see Tesla as this kind of poster child of success. You can see all the rest of the industry say this is going to happen. The fact that Europe has really doubled down on, green, we want clean energy. And I think with the new administration in the United States now, again, an extra sense that, hey, this is really important. We're going to do this. How do we do it? And so a huge challenge is within just kind of the politics are, how do, and this is where Lucy is really such an expert and so articulate, is how do we have green energy, but also be a society that really needs to mine a lot of material. And that's a kind of a huge philosophical conversation that is also a huge part of this gap. When most people, Edith, we've been involved with a lot of these discussions, when most people, even in industry, think of mining, they think they've got this dirty vision in their head that, it's kind of always the worst case scenario. And so how do we realize that, this can be done in a new way? It can be done sustainably. In many ways, mining has earned kind of its reputation. And so how do we change that going forward to where we can realize that, there are challenges, but there's a lot of opportunities to do it right?
Excellent. Well, I was just going to sort of wrap things up on the policy side, and Jesse just did it beautifully for me. And I'm glad we kind of wandered into that policy world. I'm going to sort of pull us back into kind of the geoscience framework in just a second, but I wanted to take just a second. We're at about the top of the hour now, so we're going to have about 15 or 20 minutes more of Q&A. I have noticed a lot of questions in the Q&A that are super specific to individual things that our panelists bring to the table, and I just want to, on behalf of all three of them, offer that they are all available on LinkedIn, and one of the reasons they agreed to come and be in this panel discussion today is to connect with all of you. So if anyone would like to follow up after this, I'm looking at all of you and hoping you are nodding your heads. If anyone would like to follow up afterwards, please do reach out to Andy and Jesse and Lucy on LinkedIn or to me, and I'll be happy to try to put you in touch with someone who can answer your question if I cannot. Certainly we want to envision this conversation as just the starting point. And if there's something really specific that you want to discuss, just consider this your cup of coffee introduction, and please feel free to take it forward from here. But I want to take just a little bit different turn at this point, and I'm encouraging all of our panelists too. Remember, you're going to have that minute and a half at the end for your summary statement. So if you have that l'esprit d'escalier and you forgot to say something, write it down and we'll have a chance to get back to it. But we have a question here about geoscience skills gaps. How concerned are you about a skills gap going forward to support the development of these supplies for energy minerals for this new global economy? Do you think that raising awareness is enough, or do you think that there are other things we should be doing as an industry, as academics, to make sure that we have the skills in place to meet the needs of energy storage supply chains? Lucy, I'm gonna call on you first for that one.
It's a really good question, Edith. And, I think it's partly down to the fact that, as Jessie just touched on, when people think of the mining industry who aren't involved in it, generally the image that comes to mind is of a coal mine or a tailings dam that's collapsed. And, the mining industry has a pretty bad reputation in many parts of the world. I think as an industry, we've traditionally been quite nervous of engaging with the general public and actually saying these good news stories and about telling how, and telling that story of how crucial mining is to our daily lives. That phrase that if something hasn't been grown, then it's been mined, just shows quite how prevalent it is. But I really think that, a lot of the skills gap is a real issue. And partly that's because people see geoscience as part of the problem that's actually contributing to climate change. It's geoscientists who found oil and gas deposits. It's geoscientists who've been extracting coal. It's geoscientists who've been involved in these awful tailings dams collapsing. And isn't that awful? Whereas actually, if you generally talk to people about renewable energy, and there's even in the last year, there seems to have been a real sea change in people's attitudes towards climate change, and realizing that we really need to act now if we want to have this energy transition and move away from our carbon-based economies. And so people really seem to be quite passionate, especially youngsters who we talk to in schools and who are considering university careers, are really passionate about doing something that's positive for the planet, being more sustainable in their daily lives. And then when you suggest to them, why don't you go into the mining industry, seems to be that kind of like, oh my God, why on earth would I go into the mining industry if I care about the planet? Whereas actually, I'd argue that as geoscientists, we're the ones who have this toolkit to help us understand where these resources come from, how we can extract them efficiently. We don't just need to understand the rocks now, but actually we need to be able to embrace technology. We need to be able to talk to people further up the supply chain. We need to be able to connect with chemists who can tell us how to extract these materials in a way without having to roast them to high temperatures, for example. So there's a whole suite of skills that we need. I think just as an industry, we need to get much better at shouting about the good stuff that we do, and also telling that story about how we're going to be so crucial over the next few decades for combating climate change and for the energy transition. And actually, yes, there are still some mining companies who aren't particularly responsible, who aren't being good citizens, but you're so much more likely to change an industry from the inside than you are from standing outside and being like, oh, I think it's bad, and then using the products of it anyway. So, yeah. I can't even remember what the original question was now. It's something about skills gap.
Well
Sorry.
said, well said. And I'm gonna throw the question next to Andy. And I recognize, Andy, that although you do drink beer with us, you're not a geologist yourself. But from an external perspective, from the market perspective, what do you see about our profession as geologists? How can we meet the skills needs of the future, and how can we help to change the perception of our industry so that we can bring you more medals?
Well, being the outsider, I suppose, I think, I completely agree that the geoscience, the upstream side of this is where the biggest skill gap lies, and is where the most value can be added today. The critical minerals of yesterday, or even when I came into this industry, aren't what the critical minerals of tomorrow are going to be. And I think it's a really critical point that when you look at, I work with a great team of people, some of them geologists, some of them coming from other type of commodity backgrounds. No one started in lithium. No one started in graphite or cobalt or nickel. These are the emerging materials that are going to really drive this transition in energy going forward. And I think, a lot of talent goes into where the money is today, I suppose, and people are drawn into those roles. But there is a huge amount, just in the few years, that I've been in the industry and looking at these materials, you realize that it's a really small and narrow community today, even today, and it was even smaller 5 or 8, almost 10 years ago when I started off. So, it's a small group of people that actually have the experience to do this. And that is going to be so invaluable, building that talent pool and building and then getting more and more of the people, the type of people on this call into those industries. I'd urge everyone to go in, because there's so much change happening and there's so much need for new skills, need for development. And as Lucy pointed out, I think, really critically, working along that supply chain, right? And knowing, because that, where you can draw together the geoscience side of the supply chain with what's happening on the technology standpoint, that's when change can really happen pretty quickly. A lot of the lags come in the fact that you can't tie, someone working in a lab in a new battery technology with no concept or no appreciation of actually where how you would actually build up the raw material supply base to build it out. They're just thinking about the technology and what they can make happen in a lab, right? And if you can tie that together with actually the reality of where these markets are, then I think you can get to real change, and that will help push forward the entire industry. So again, I lost where the question was as well. Sorry.
No, you've done well. You've done well. I think, one of the things, and I'll throw it to Jesse to round it up, but we were talking also about skills gaps. And I think what we're drifting toward is the biggest gap is really an understanding of the system in place. And that's critically important. I think there are also other, if you'll forgive me for injecting my voice into the conversation, there are so many opportunities for us to use some of our geoscience skills that have sort of lain fallow for a while, perhaps around crystallography, around nanoscale mineralogy and layering and oxide structures in that processing and new battery chemistry space. So there are a lot of kind of muscles that we might not have flexed for a while as geoscientists that might be critically important in everything from not just mining, but processing and refining and even recycling. And so I'll throw the question to you, Jesse, in a slightly different way. If you were sitting down with a student today in a master's program, what sorts of things might you tell that student to, what sorts of education might you tell them to learn? What sorts of elements of software or training or education would you recommend pursuing to be a critical cog in this supply chain?
Yeah, sure. No, I would say just really probably trying to empower them that they probably already have the skill sets. And so that, when you get into a certain mineral exploration opportunity, it's always such a special story in every case. Every deposit's different, every mineral commodity is different. And, nobody expects you to show up on the first day being an expert in everything, but it's just having the ability to turn, look at me, I'm a tree ring scientist that never had a mining class in all of my education. And, I've managed to carve out, a little slice for myself. And, most months I have a paycheck, but it's basically just, learning, we've got the skill sets to go out into nature, to collect data, to bring that data back, analyze it, and to understand what it means, and then communicate that, whether it's with our team or with policymakers or whatever. That to me has been such a huge part of how I've survived in this industry. But I think, in general, so I would say that most of the people that are on this discussion today, you guys have the skill sets. It's just figuring out exactly, where your passion is or where the opportunities is, and how to, reach into your tool belt and use them. I would say overall though, there probably is a gap in just the special processing and refining that's involved with all these critical minerals. And, so much because there has not been a lot of these activities done in the Western world over the last decades. There's a bit of a gap there, and so it's hard to find a mentor that's a specialist in producing coated spherical graphite, because there's just not a lot of people out there that really know how to do that. But so kind of really building, I guess, on the processing and refining side, I would say there's a lot of opportunities there. And then I saw just one of the comments in the chat. I think there's huge opportunities for repurposing existing mining waste, and we're starting to see some pretty neat examples of that. The Standard Lithium project in Arkansas, to brag about my home state, looking at an existing waste stream, realizing, hey, there's lithium in this right now. It's just going right back into the ground. In fact, it can be repurposed. Let's develop a unique extraction technology that allows us to do that. In another case, look at like the heavy mineral sands mining on the Atlantic coast, where they had been discarding, monazite and just putting it back into the tailings, and realizing, hey, we can go through an extra extraction step. We can now produce a monazite sand within the United States. And it turns out that's a really clean and great source of monazite for this country. Or repurposing different mining waste and converting them to other materials. So I think there's a lot of opportunities there. And then certainly on the recycling side too, which, recycling of batteries and just a lot of innovation around that.
Yep. I mean, we're going to hear this phrase circular economy become more and more dominant, and everything we can do to extract efficiency at every step in the way is going to be a critical path item going forward. So I have us coming up on just a few more minutes of Q&A. So I've got some sort of specific questions that I'm going to ask you to bear with me and be kind of rapid fire. So rather than round robin, I'm going to ask someone to comment on the recent Japanese discovery of rare earth elements and the implications for underwater mining. Who wants to take that one?
I can try.
Okay,
I have to say, I don't know about this particular discovery, but underwater mining is a bit of a minefield, I'd say. Rare earths, obviously, the supply chain's really controlled by China. So finding rare earth deposits that are outside of China has a lot of, it's important. Undersea mining is, I think there's potentially a lot of environmental ramifications associated with it, depending on how it's going to be done. And it may not be the easiest thing to do, and it may not be the easiest thing to get the social license to operate to do either.
And political landmines as well. Yeah. So Andy,
I agree.
I have a question for you. There was a question about a single company who actually is involved in all elements of rare earth mining, rare earth supply chain outside of China. My question to you is, what supply chains are you aware of where there actually is a local from mining to market supply chain that is actually all in one place or all in one country? Anybody, anywhere other than China?
The whole supply chain in another country that's not China. I know there's Makango Resources, who've got a rare earth project in Malawi. I don't know, I think their supply chain is outside of China, but I don't think it's all in one country.
Okay. I mean, we all know that we have Mr. Musk in this country attempting to do that with lithium hydroxide.
Yeah, and I think that's a really, like I mentioned a bit earlier, I think that's a really critical way that you can address some of these supply chain security issues, because if you can localize the refining step in the supply chain like China have done, then it means that you can draw a pool of raw material from various other parts of the world where you may not be competitive domestically doing it. So yeah, I think that's a really exciting development in the US to have that hydroxide to cathode through to the battery cell production and EV production all in one country. It would be the only case of that outside of China today.
Okay. And last rapid fire question for Jesse is, and I know this is something that is near and dear to your heart. How do we raise the profile of this topic so that these conversations occur on a larger scale? And before you answer that, Jesse, I'm going to just put in a plug for that is exactly what is behind this conversation, because we all not only want all of you who are students and emerging professionals to have contacts who are actually in the business, but we want everyone in our greater society to be aware of the issues and problems and opportunities. So Jesse, any quick suggestions for how we elevate this conversation?
Yeah, I think you answered it for me. I mean, I think just, events like this, and the more, I think Lucy made a really good point earlier about the fact that, in the past, the mining industry has been really shy to have have conversations with the public. And so I think there's a huge opportunity, and especially when, let's say, something bad happens in the industry. So, not to pick on Rio Tinto, but like the what happened in Australia with, with the important native site that was destroyed. When you have something like that happens, I think that it's really important that we need to find a way as an industry to immediately respond to that with, hey, that's not what we're trying to do here. That's bad. That should be punished. And so I think we have to find ways to really just improve the messaging across the board. And I think that, hopefully, the three of us are all part, and a lot of people on this call are part of a generation that really sees an ethical, moral, professional responsibility to make sure that it's done right. Personally, I've abandoned my climate science path because I was tired of beating my head against the wall and people not listening to me about climate change. And I thought, well, there's so many people already doing that are doing a great job and nobody's listening. But if I can get in within industry and get, behind enemy lines as far as, that goes, and be an effective voice for change. And that I could just tell you that I've been on Capitol Hill and had conversations where if it was, Jesse, the tree ring scientist, trying to have a conversation, it would have gone completely different. But if it's Jesse with U.S. Critical Minerals talking about responsible mining, they kind of look at you like you're an environmentalist. Like, what's that? And you rarely hear the word environmentalist in the mining industry without an expletive put in front of it, and that's a problem.
So your recommendation is fight from within. I love that. So as I promised, I'm going to offer you all a 2-minute slot to make a final comment, and I will cut you off. I will get the hook, and I'm going to go I'm going to make Jesse go first, and then I'll let Lucy go next, and then Andy, I'll put you at the end so that you won't have to go after Jesse. And but before we do that, I want to just remind everyone that this discussion is being recorded and it will be posted in the event archive on the SEG website at segweb.org, and also on the SEG YouTube channel. And also remind you that if you would like to connect with me or with any of our panelists, Deanne has posted all of the LinkedIn information in the chat, and I'm sure she will repost that near the bottom if you would like to reach out to us. And I'm assuming that you are all okay with that, because I haven't seen anyone throw their hands up in horror. So anyway, I'm going to go around and ask for your summary comments. And I wish that we could have covered every single question that came in. We tried to combine some of them. Those of you that haven't had your question answered, please reach out to us and we'll do our best to put you in touch with someone who can answer it. So, Jesse, I'm going to give you the first last word. What summary comments would you like to share?
Yeah, just that, the energy transition is well underway, and that there's a lot of opportunities for geoscientists across the board. And that I think that we all have, I think the future looks bright, essentially, for all of us. And so, I think it's really about empowering yourself. If you want to be involved in this industry, that there is a place for you at the table. Encourage you to really work on building networks, and do a quick brag to Andy and the guys at Benchmark Minerals. They've really created a huge community around this story. They're excellent hosts, and they put on a lot of really great events. And so encourage anybody that's interested in these supply chains around particularly the battery materials to really follow these guys and the discussions that they have, the events that they do. They're excellent sources. I'll brag on Lucy as well, so she doesn't, have to mention it. She's done an outstanding TED Talk that I encourage you guys to view and then to share with your peers, because it really explains the story of how we how we paint a new picture for 21st century mining, and it can be done right. It needs to be done right, and a lot of that involves opportunities in our backyards and back doors to really build local supply chains. I think certainly COVID has kind of underscored the importance of regional supply chains, but there's a lot of good reasons to do it. I just end on like this is not as an American, but I think it goes across the board that this is an opportunity for everybody. No matter your politics, this is about mining opportunities. This is about advanced manufacturing opportunities. This is about national security. This is about energy security, you name it. It's all wrapped up into the story. And so, in a world that is so divided, I think this is a great opportunity where everybody's got a seat at the table, and encourage us to work together to make sure this is done right.
Excellent. And right on time, Jesse. Good job. Lucy.
Thank you. And thank you, Jesse. That is a lovely shout out. But yeah, I absolutely echo what you've been saying about Benchmark as well. They really are the industry leaders in letting you know what's actually happening in the battery space. I suppose my closing remarks are very much that I think we've hopefully given a really good flavour this evening of quite how resource intensive this energy transition is going to be, and that it's not just finding these raw materials, but it's how we can process them, how we can refine them, and how we can make sure that these supply chains are as responsible as possible. And I think as geoscientists, we've got such a crucial role to play in that. Yes, we need to find a lot of new mineral deposits. Some of those are going to be in far-flung places. Some of those are going to be much deeper undercover. So we need to use new technology to help find them. But perversely, some of those are going to be closer to home as well. And we need to change this narrative about mining's bad. Actually, mining's playing such a critical role in our future lives and our future energy systems that we need to make sure that it's being carried out as responsibly as it possibly can be. And we've touched on ESG, environmental, social, governance things slightly today, but the social license to operate is going to be such a key factor in whether these projects are going to be successful and whether we can provide these raw materials. And it just means that we need to be responsible citizens, basically. And yeah, as geoscientists, we've got such a crucial role to play in that. So I think it's an exciting time to be getting involved in the industry.
I couldn't agree more. Excellent. And Andy, I'm going to give you your chance for your last word, and then I'm going to take 2 minutes to have my last word. Go ahead, Andy.
Great, thanks, Edith. And thanks to Lucy and Jesse for the nice words about Benchmark. I think that speaks to the first thing I'd like to say, which is for anyone looking to get involved in this battery supply chain or the battery raw materials or new energy economy, these are amazing communities to be part of. And the one thing I've found in my almost 10 years, coming from an outsider perspective, is that when you're working in these niche or more less mature raw material markets in particular, they really are welcoming, friendly communities that want expertise. They want new people to join, and I'd really encourage everyone on the call to connect. And like Jesse was saying, networking is key. From a market perspective, I suppose just to round up, when we from a market research perspective look at this whole supply chain and the build out, the biggest area, what raises the biggest risk in terms of a bottleneck and preventing some of this growth in the short term is the availability of these raw materials and the availability to refine these raw materials. So, it's really important work that the people on this call are doing, and the panelists and everyone around this sector. And I'd encourage people to get involved, join these communities, and play a part in what's going to be so important in building, whether it be not just the availability of raw materials, but the mining, like Lucy says, sustainably, and the localization of supply chains, and that's to the benefit of the global community. So thanks for the chance to take part in the discussion today. It's been really fun.
Well rounded up, Andy. That was perfect. And I am going to ask for Deanne to please put up our last slide while I make just a few comments. And I want to emphasize what I hope everyone has taken away from this conversation is just how incredibly vibrant and welcoming this industry is. I've had experience in both the oil and gas industry and the mining industry. And what I find really unique about this nexus that joins the two of energy minerals for battery storage is that it is a world that thrives on change, that is growing and opportunistic and just really, really exciting to be a part of. So I encourage you all to read something different, think about some of these new companies we've talked about today, sort of open your perspective to everything that's going on in this rapidly evolving and really critical energy supply chain for our new global economy. So I'd like to say a huge thank you to our panelists, to Jesse, to Andy, to Lucy, for giving your time today, sharing your thoughts. Again, all of our LinkedIn information is available in the chat, and the recorded version of this session will also be available. Our next event in the series will be in April, so please watch your segweb.org and social media for an announcement of which segment of the supply chain we will tackle in depth next. Now that we all have a great appreciation for the importance of the critical minerals supply chain from our panelists' discussion today. So again, just thank you, and a special thanks to Jesse, to Lindsay Ross, and Murray Hitzman, and the other members of the AAPG Critical Minerals Committee who sort of first started this idea of having panel discussions so that everyone could be part of the conversation. Thank you to all our attendees, to all the SEG members, and to the staff who did such a wonderful job of putting this event together. I believe our discussion is at an end. I'm just checking to make sure. Oh, one final thing. When you do say goodbye and log off your system, you will get a survey with some feedback requests. And we would be so grateful if you would provide us your honest feedback. And most of all, we look forward to connecting with as many of you personally as we can in the future, either virtually or one day, possibly hand to hand. And thank you again, all panelists, attendees, and SEG. I believe we are at a close. So I will say goodbye. Everyone stay well, and we'll see you on the tiny computer screen again soon. Goodbye, everyone.
Yeah, thanks, everyone.
Thanks, everyone, and thanks, Edith.